Alright, the translation t, which takes a point and subtracts 2 from the x value and adds 3 to the y value, maps the point 3. So here I'm just going to subtract 2, and I get 1. And I have a negative 1, I'm going to add 3 to that, and then I get 2. That's all there is to that. The translation t, okay. For this translation, we're adding 3 to the x value, which gives us 1, and we are subtracting 1 from the y value, which gives us negative 6. That's all there is to it. Done. Alright, given BD bisects angle ABC, we're going to draw our own diagram here. A, B, C, alright, and BD bisects the angle, bisects it, so these two angles are congruent. ABD is 2x minus 5, or sorry, 15, and CBD is x plus 35. What is the measure of angle ABC? Okay, well, since the angles are equal, I set 2x minus 15 equal to x plus 35. Subtract x, I get x minus 15 is equal to 35. I add 15, and x is equal to 50. Alright, take that value and plug it in, and I get 85. And here I get 85. Alright, and I want ABD, the whole thing. So 85 plus 85 is 170. Or I want ABC, which is 170. Alright, so our diagram is not accurate, but it doesn't need to be. We just need the visual to help us get through the problem. Next problem, you're given AX bisects BAC. Alright, so I have angle BAC. Okay, and I have AX bisects angle. So these two angles are the same. BAX is x plus 25, and CAX is 4x minus 11. What is the measure of BAX? Okay, so since the angles have the same measurement, I can set x plus 25 equal to 4x minus 11. So I subtract x. I get 25 is equal to 3x minus 11. Here I'm going to add 11. So I have 36 is equal to 3x divided by 3. And x is equal to 12. I'm going to take that. I'm going to plug it in here because I want measurement of BAX. So measurement of angle BAX is equal to x plus 25. Plug 12 in for x, and so I get measurement of angle BAX is equal to 37 degrees. Done. Alright, given BD bisects angle ABC, what is the value of x? Alright, so I have angle ABC, and I have ABD, which is 2x minus 10, and CBD, which is x plus 30. It also says that BD bisects the angle, so these are the same. So that means I could set 2x minus 10 equal to x plus 30. So here I'll subtract x. Then I get x minus 10 equals 30. Here I'll add 10. And I get x is equal to 40. Done. Alright, given x, z bisects wxy. Okay, WXY. WXY. All right, XZ bisects angle. All right, WXZ is 3x minus 12, and ZXY is x plus 18. So since the angles bisected and these angles are equal to each other, I could set the expressions equal. Right here I'm going to subtract x. I get 2x minus 12 equals 18. So I have 2x is equal to 30. Divide by 2, and I get x is equal to 15. Done. That's all there is to it. All right, you're given that AX bisects BAC. BAC. And that BAX, I have AX is bisecting the angle. All right, these angles are the same. All right, BX is 3x plus 12. CAX is 5x minus 4. All right, so what is the value of x? So I set 3x plus 12 equal to 5x minus 4. So I subtract 5x, and I get negative 2x plus 12 is equal to negative 4. I subtract 12, so negative 2x is equal to negative 16. Divide by negative 2, and x is equal to 8. Done. All right, XY bisects TXP. All right, here I have TXP. Okay, XY bisects the angle. So I have 4x minus 2. Then I have x plus 20. All right, the angles are equal, so I set 4x minus 2 equal to x plus 20. Subtract x. I get 3x minus 2 is equal to 20. Add 2. 3x is equal to 22. Yep. Divide by 3. All right, so x is equal to 22 over 3. Done. Find the value of x. All right, they tell you that measurement angle 1 is x minus 5, 6x minus 5. 2 is 4x, and the whole thing is 120. So I'm going to take 6x minus 5 plus 4x and set all that equal to 120. All right, add like terms, I get 10x minus 5 is equal to 120. Add 5, I get 10x is equal to 125. Divide by 10, I get x is equal to 12.5. Done. All right, the points that they show here form a triangle and plotted on a coordinate plane. Using the distance formula, calculate the following measures to the nearest tenth of a unit. Oh, wow. Okay, so AC. So I have to use the distance formula 3 times. Looks like it. Okay, so I have the distance formula. x1 minus x2 squared plus y1 minus y2 squared. Alright, so to figure out AC, I just have to be careful with your work. Easy stuff to do. y1, which is 4, minus y2, which is negative 3. Alright, so I have negative 3 plus 2 squared plus 4 plus 3 squared. So I have negative 1 squared plus 7 squared. 1 plus 49, which is the square root of 50. And that breaks down to 2 times 25, 5 times 5. So I have a pair of 5s, so it's going to be 5 square root of 2. Alright, so I have that is equal to 5 square root of 2. Alright, next one. I have AB. AB. So it's going to be negative 3 minus 1 squared plus 4 minus 3 squared. I have negative 4 squared plus 1 squared. Now I have 16 plus 1 square root of 17. Done. Alright, then I have BC. BC. I'll do the work over here. BC is equal to 1 minus negative 2 squared plus 3 minus negative 3 squared. So I have 1 plus 2 squared plus 3 minus negative 3. So that's 6 squared. Alright, and I have 3 squared plus 6 squared. So that gives me 9 plus 36, which gives me 45. Can I simplify that? 3 times 15. 3 times 5, yeah, I have a pair. So that gives me 3 square root of 5. Alright, what type of triangle is it? All the sides have different lengths, so it's going to be a scalene triangle. Done. Alright, rewrite the following declarative statement as a conditional statement. Isosceles triangles have congruent base angles. Alright, so you could say if a triangle is isosceles, then it has congruent base angles. Alright, turning it into a if-then statement is what they mean by a conditional statement. Alright, that's all there is to it. On to the next problem. Rewrite the following declarative statement as a conditional statement. All equilateral triangles are equiangular. Okay. If a triangle is equilateral, then it is equiangular. Alright, so converting it into an if-then statement is what they mean by a conditional statement. That's all there is to it. Alright, we have a proof here we have to complete. EF is congruent to HG. Alright, EF is congruent to HG. And J is the midpoint of EH and FG. Okay, that's given. Then it says EJ is congruent to HG. Well, I know J is the midpoint. Okay. So that's just definition of midpoint here. And FJ is congruent to GJ. That's just definition of midpoint. And now I know the triangles are congruent by what shortcut? SSS. Alright, M is the midpoint of EZ. That's given. They say E is congruent to Z. That's given down here. All right, ME is congruent to MZ. All right, that's just by definition of midpoint. All right, for statement 4, it says vertical angles are congruent. All right, where do I have vertical angles? I have angle 1 is congruent to angle 2. I forgot to state this before. I forgot to state that E is congruent to Z. All right, so the triangles are congruent by what shortcut? Angle, side, angle. Angle, side, angle. That's all there is to it. Done. All right, estimate the degree measure of this angle. Okay, this is 90 degrees. Half of that's around 45 degrees. So I'll say this is roughly 45 degrees. It's just an approximation. Done. All right, estimate the degree measure of this angle. All right, maybe this is around, you could say 35 degrees or 45 degrees. All right, it's definitely less than 90, right? All right, so just as long as you're within that range, you're good. It's just an approximation. All right, using only a compass and straight edge, perform the following constructions. All right, below the tutorial videos are videos for how to do all the different types of constructions, so take a look at those. Constructing line through point A perpendicular to line L. Okay, below all the tutorial videos are videos that show you how to do all the constructions, so take a look at those. All right, in the diagram, connect the letters to form ABC. All right, a triangle ABC. Using the distance formula, calculate the lengths of the sides to the nearest tenth of a unit and classify the triangle. Okay, gotta do a little work here. x1 minus x2 squared plus y1 minus y2 squared. All right, first thing I have to do is figure out the coordinates for all these points. Let's see, where's my center? Right there. All right, so 1, 2, 3, 4. All right, -4, and then up 1. That's for that one. Then I have right 2, and up 1, 2, 3, 4, 5, 6. All right, and then I have right 1, and down 1, 2, 3, 4, 5. Alrighty. All right, so if I want to figure out AB, all right, it's going to be -4 minus 2 squared plus y1, which is 1, minus y2, which is 6 squared. So that's -6 squared plus -5 squared. So I have 36 plus 25, 41, which is square root of 61. All right, so AB is the square root of 61. All right, now I'm going to go to BC. Let's do that in a different color. BC is going to be 2 minus 1 squared plus 6 minus 5 squared. So I have 1 squared plus 1 squared. So I end up with 2. Is that right? See, that's off. That's supposed to be -5. Alright. Alright, caught myself there. Watch out for those negatives. See, even I miss them sometimes. Alright, so that's going to be negative there. So it's 6 plus 5, so it's 11 squared. This is supposed to be 1 plus 1, 21, which is the square root of 122. Okay, so I'm going to have 2 times 61 here. So it's just the square root of 122. All right, so I have BC, which is the square root of 122. All right, watch out for those negatives. All right, and then the last one. I have AC. All right, so I have x1, which is -4, minus x2, which is 1, plus y2, which is 1, minus -5 squared. All right, so I have -5 squared plus 6 squared. So I have 25 plus 36, which is square root of 61. All right, so AC is the square root of 61. So that means this is an isosceles triangle. Done. All right, in the diagram, the letters form this triangle using the distance formula. I have to use the distance formula again. All right. After doing these problems, you should have the distance formula ingrained in your mind. Okay. So for A, there's my origin. Gotta go back 2. I'm gonna go up 4. For B, I'm gonna go right 5. I'm gonna go up 3. And for C, I'm gonna go left or right 0. I'm gonna go down 4. Okay. Figuring out AB, I'm going to have -2 minus 5 squared plus y1, which is 4, minus y sub 2, which is 3 squared. Then I have -7 squared plus 1 squared. So I end up with 49 plus 1, which is square root of 50. So I have 2 times 25, and I have 5 times 5. All right, so I end up with AB, which is 5 square root of 2. All right, going on to another segment. BC is equal to 5 minus 0 squared plus 3 minus -4 squared. 5 squared plus, that's going to be 3 plus 4, so 7 squared. So square root of 25 plus 49, which is going to be 74. Can I simplify that? 2 times 37? Nope, I cannot. So BC is equal to square root of 74. All right, then I have AC to do. AC is equal to -2 minus 0 squared plus y1, which is 4, minus y2, which is -4 squared. All right, so I end up with -2 minus 0, that's -2 squared, plus 4 plus 4, which is 8. So I end up with 4 plus 64, which is square root of 68. So I end up with 2 times 34, then I have 2 times 17. I have a pair, so AC is equal to 2 square root of 17. All right, so all of these side lengths are different. That means I have a scalene triangle. Done.